and set up from the current slide. All right, good deal. Oh, okay. If you fill that out, you would think English people could write better than that, wouldn't you? No, I didn't say that out loud, did I? Okay. All right, enough of that. Where we are, and were any questions? Let's see if there are any major announcements. Let me tell you this one. It really has no immediacy to it. In spite of the fact we got a text at 7 o'clock in the morning, and it went on forever. I don't think I've ever gotten such a long text that we're getting a new blackboard system in January. And I thought, why did I need to know this at 7 o'clock in the morning? What was, nothing to do now, nothing to do next week, nothing to do for probably a month or two, but we're going to get a new blackboard system. So evidently that's big news, okay? For us, there's supposed to be a fairly major adjustment we have to make. Hopefully for the students, it'll be pretty much transparent, hopefully. So if you are here next term, which I imagine you will be, stand by if there's a few glitches in Blackboard, because there's always been glitches in Blackboard. All right, let me think if there are any other major announcements. I know the volleyball team will be playing some this weekend, but I don't have those dates and places in mind. The NASA Community College Aerospace Scholars Program will be accepting applications through 16th of October. That's less than 2 weeks away now. So if you are interested in at least finding out about it, I've got the sheet on paper in the classroom 255. I'll be glad to share it with you. Okay. I'm on, right? I got you in the right place. Okay. Now, there's probably others. I can't think of them now. If any of you are in a first mini-term course or know of someone in a first mini-term course, and it doesn't look like you're going to be able to pull out, not you, but them, a D or anything higher than a D or an F in the course, Friday, tomorrow, is the last day to withdraw from a first mini-term course. And final exams will be next week, whatever the last day of class is for that course. Or Friday is how they have it on the schedule, but I don't see how you can give all the mini-term tests on Friday. I know I couldn't. Remind me? Amber got it. But now finding you. There you are. Okay. Anyone else coming in Sister Caldwell? Okay. And second mini-term starts in the following week, not next week, but the following week. First day of class is Monday, so you can register for second mini-term classes right now if you choose. I'm sure there's others. I can't think of them now, so let's move on to example 6 again, okay? I mistakenly did the example 6 that was on the slide set without looking to see that this is not the example 6 in the book. On the slide set, they left off 3x plus in the denominator.
Oh, and then the top there's only 3.
Oh, you're right. It is not a 3 there. Okay, I should rewrite it then, shouldn't I? But I'm lazy. Okay. Now, find the inverse function of this. Oh, wait, before I get started. Any questions on anything we've done so far? Okay, and just make sure everybody's heard this. Okay. The test will be Tuesday. Hopefully we're going to finish these last 2 examples today. The test will be Tuesday on chapter 1, and that's 1.456. That's what your quiz covered. So you'll be tested on that material again. Not going to be the same questions by any means, but similar type concepts being tested. And then 7, 8, and 9 that you haven't been quizzed on, but those will be covered as well, including what we're doing here. So, bring with you a formula and equation sheet. That doesn't mean that's all you get to put on it. You can write down anything on that piece of paper that you want to, front and back, but it needs to be an 8.5 by 11 piece of paper. No poster board, okay? That wouldn't work too well. Your neighbor at the table would not appreciate that. So 8.5 by 11, whatever you can fit on front and back. And I've had people ask me, can we type it? Sure, I don't care. Can we write small? That's up to you. Write down whatever you think might be useful to you, because I don't count math as a memorization course. That's not what it's about. It's how to use material that you can look up and find. Okay? So, be prepared. I don't have all the quizzes in. I wish I did, so I could return them to you today. But if on your way out of class today you want to see your quiz, what you may have missed, so you don't make that same mistake again, please stop and see your quiz. Now, I hope I don't have to say this, but let me say it anyway. Don't be taking pictures of your quiz and things like that either, because if someone else sees that, then they see right answers, and if they haven't turned it in yet, they get a boosted grade, not from anything they knew, and that basically almost deflates your grade. Okay, it doesn't really, but it seems to. So please just keep it to yourself. What you see on the test, quiz. All right, but I do want you to learn from your mistakes. And by the way, any of you that turned it in earlier, you could always, after I've got it graded, you can always see it. I just can't return it until I get them all in. So for people who haven't turned in the quiz and don't get it in today, they're going to have to do the quiz before they take the test on Tuesday. Preferably before they come to class, but if they come to class and haven't done the quiz, they either have to do the quiz or ask me politely to give them a 0. Now, I don't want to give them a 0, but if they ask politely, I just can't refuse. So please get your quizzes in, preferably today or tomorrow. Now, tomorrow I'll be on the Birmingham West Campus in Dr. Pruitt's suite of offices, and Josh will be there too, I'm sure. Let's see, there you are. Okay. And so please, if you have any questions, you want to turn in a quiz, I'll be there from 8 to 12 pretty much. I know there's one time I'm going to have to leave the office and go pick up something and come back, but other than that, I should be there pretty much 8 to 12. I've got a meeting that's going to go from 12 to 1, so I won't be available then, but you can turn it in to the secretary. The office number is on the academic building. That's the B Hall, and it's B122 at the very end of the building on the first floor. There's a ground floor and a first floor. On the first floor, the last thing, or first thing, depending on which way you're coming in. If you're coming in from the baseball field, the gym, the tennis courts, that area, you come up that half flight of stairs. That when you get to the top step, the door immediately on your right is Dr. Pruitt's suite of offices. And if I'm in the meeting or out of the office, the secretary there will take it and give it to me when I come back. Now, if it's after 1 o'clock, there's a good chance I'm not going to be back. So, well, I'll probably be there a while. But if it's well after 1, I will have already gone home. Don't turn it in there. Bring it to class on Tuesday. Okay? Or bring it Monday. Monday I'll be here. Office hours Monday, 8 to 10 and 3:45 to 6 here on this campus. So, plenty of opportunities for you to get. And here it is now. Oh, no, that's something else, isn't it? All right. I get to fill this in. Okay. Oops. And I didn't mark you here, did I? No, I did. Okay. Okay. All right. And here is Charles. Okay. Now, for those who did come in late, this will be one time, go back and listen to the first part of this class, because I gave some information there were very useful for you coming to take the test on Tuesday. Okay? So please go back. I don't want to use class time to rehash all that. All right. Any questions before we get going today? Keeps bothering people up and down the hall. Okay. Now, as I was starting to say before, and did say before, the example 6 that was on the slide set that we did last time is not the same example 6 as is in the book. This is sort of the example 6 in the book. It says, find the inverse functions. How do you proceed with that? This one's a bit more work for that first step. What is the first step? Say again? Say it one more time.
You equal it to y so that
Okay, we're going to do that later. We need to do something first. Anyone remember what you need to do first? Say again? Okay, that's later. Okay, what's first? Make sure it's a one-to-one function. You know, the last one was a linear function. That was easy. This is not a linear function. This is what we call a rational function, because it's a ratio of two polynomial functions. Ugh. So, how are we going to determine if this is one-to-one or not? Unfortunately, I don't know of any way except graphing. Okay, so let's do a quick graph, which is not a bad idea, because you can almost bet that any test coming out of the test bank for this text is going to have some graphing on it, at least one, maybe two. So let's see what we got. We'll erase all this later, but let's do it now. Okay, there's my y-axis, my x-axis. Let's tick off a few points. 1, 2, 3, 4, 5, 6, 7, 8. Negative 1, 2, 3, 4, 5, 6, 7. Positive 1, 2, 3, 4, 5, 6, 7. And negative 1, 2, 3, 4. Something like that. Okay, now, this is one thing that bugs me a little bit about this kind of problem. We're going to cover this kind of problem in 2.6. We're in 1.9 now. So why is he giving us this to do? Now, one thing you could do is set up a t-table, pick points, and plug them in. That's a little long, a little tedious, and you might not pick all that great a point. So let's see if we can do it a little more systematically. You'll learn this in 2.6, but let's hit it now. Okay, first, what are two, usually, not always, usually 2 points that are of great interest to you that are fairly easy to pick out on any function? Say again?
0, 0.
Okay. That's a point that's easy to pick out, I'll guarantee you that. But 0, 0 isn't on this graph, is it? Now, if what you were meaning, which I'm sure it was when x is equal to 0. That's what you meant, right? Okay, what happens when x is equal to 0? X equals 0 is going to place us on the y-axis, by the way. So when x equals 0, what is this function? 5 over 2, which is 2.5. That would be right about there. Good point. And then the other one was when y is equal to 0. I don't see a y here. Where is my y? F of x. So f of x equals 0. Okay? And when that's equal to 0, what on the right-hand side would make that equal 0? Would it matter at all about the denominator? No. Doesn't matter what the denominator is. That's not going to make that 0, is it? What will make it 0? Move upstairs from the denominator. What you got? Numerator. The only way a rational expression can be 0 if that numerator is 0, right? 0 over 3,485,815 and 2/3 is still 0. If that numerator is 0, the y is 0, right? 0 over anything is 0. With one exception, 0 over 0 is not defined. Actually, it's indeterminate. We'll live with not defined right now. So, what would make y 0? 5, yes. X equal 5. Okay? So when x equal 5, 1, 2, 3, 4, 5, and y is 0, that means you're on the x-axis. Those we call the intercepts. The x and the y and the x intercepts. Okay, we got 2 points on the graph. That's not enough to go on. Okay, so I'm going to show you now a couple of tricks that later will become methods. And I think to do this, for the first one, let me ask this question. Is this function defined everywhere? In other words, what is its domain? All real numbers except, what's the exception? What can you never do? Say again? Yes, the denominator cannot be 0. So let's say that, let's write that in math speak, and that would be the denominator, 3x plus 2, cannot equal, not equal to, 0. Solve that inequality. How do you do it? Solve for x. Subtract 2 from both sides, and that gives you 3x, this adds a 0, cannot equal negative 2. And then do what? Get out of there. So again, divide both sides by 3, and that gives you x cannot equal negative 2/3. One of my favorite numbers in the world. Okay, now where is that? That's right about there, but because x can't equal that, I'm going to make it red. You cannot ever be, x cannot be negative 2/3. So it can't be negative 2/3 there, or there, or there, or there, or there, or there. Anywhere it can't be negative 2/3. Now, you'll learn this later, but there's no reason not to tell you now. That's called a vertical asymptote, meaning the function cannot touch it or cross it. What's your name, please? Raquel got it. Okay. All right, good deal. Now, I've told everybody who came in a little later, be sure you listen to the first part of this class on YouTube video because stuff about the test is told there. So go and listen to that. All right. Now, the function cannot touch or cross it. Okay. Now, here's another thing. I'm going to do something that's not absolutely necessary, but it makes it a little easier to do. I'm going to rewrite this as minus x plus 5, just rearranging the order of that one, over 3x plus 2. That didn't change anything except how it looked, right? Except it flashed it off, okay? Now, the next feature that we'll learn in 2.6, you don't need to know now, but to do this problem well, you sort of do. Well, you don't have to, but it helps a lot. Is what is the end behavior of this rational function? In other words, what happens when x's get very, very, very large, either negatively or positive? Well, to determine that, and this is a trick, you look at the ratio of the leading terms. Because this 5 is not going to change anything for very large x's, large or small. That's going to govern. The 2 won't change anything. That's going to govern. So look at the ratio of the leading terms, and what is that ratio? Negative 1/3. Did I hear that? Wonderful. Negative 1/3. That is called the horizontal asymptote. Okay? Now there's a difference between a vertical asymptote and a horizontal asymptote, though they're going to look sort of similar here. Negative 1/3, that's going to be right down about here, and it's going to continue horizontally this way. Okay. Now, I did it in red. That red is not as bad as this red. The vertical, you can't touch it. You can't cross it, ever. Horizontal asymptote, you sure can. You can actually do this if you wanted to. But what that means is in the long run, that's where your function is going to wind up. Near negative 1/3 here, and near negative 1/3 way out there. So that's where the function's heading. Now that we have those two pieces of information, you realize this function has no choice but to what am I trying to do? Get my pen back. Be approaching the vertical asymptote here, can't touch it, okay? And then coming down here and approaching the horizontal asymptote. It could touch it if it wanted to, but it's going to get closer and closer to it. So guess what? This function in this side is 1-to-1, okay? Now, we don't know anything about what's going on this side. So what you can do there is pick a point. Pick a point, an x value, something to the left of this vertical asymptote, like negative 1. Well, let's plug that in, see what we get. F of negative 1 is equal to, now I don't care which one you use. Let's do 5 minus a what? A negative 1 divided by 3 times a negative 1 plus 2. And that will be 5 minus a minus 1 is 6. And 3 times a negative 1 is negative 3 plus 2 is negative 1. So what is when when x is negative 1, what is your y? Negative 6, somewhere way down here, folks. I don't even have it on the screen. So you know what that means? That means the function does this. It's approaching the vertical asymptote as it gets closer to negative 2/3, and it's approaching the horizontal asymptote as x gets very, very large negative. All you needed was 1 point here to find out where this function is going. Guess what? That's also 1 to 1. Okay? It's just not 1 to 1 here because it's not defined there. So it's a decreasing function here, it's a decreasing function there. So guess what? Does this have an inverse? As long as you don't have x equal negative 2/3. Yes, because it's a decreasing function everywhere, it is 1 to 1. Okay? So a lot of stuff that we haven't hit yet. So I guess I need to erase all that because I need more room to write. So everybody got it? Graph shows it's a 1 to 1 function. All right. Sometimes that's the hardest part of these problems, okay, is determining whether it's 1 to 1. Okay. I hope I asked if y'all needed that any longer. I just started erasing, sorry. Okay. I don't think I need this anymore either. So, and probably not that either. So we've determined it's 1 to 1, which means it does have an inverse, so we can proceed. If it wasn't 1 to 1, it doesn't have an inverse, there's no reason going any further. So, what's the next step? A couple of you have said it. Okay, change the f of x to y. So y is equal to minus x, which way you want it? First way? It doesn't matter. We don't need to change that. 5 minus x over 3x plus 2. All right, done. What's next? Yeah, switch the x and y. So you tell me what to write. X is equal to 5 minus y over 3x. I mean 3, what did you say? Okay, 3y plus 2. Right? Got it? Now what do we need to do? Solve for y. Whoa. Big order here. We got 2 y's. One's in the numerator, one's in the denominator. That's not easy to isolate. So what would you suggest we do first? What do you like least about that?
You can multiply the denominator.
Yes, multiply both sides of the equation. And by the way, let me go back up here. I did mean to leave this one. X cannot equal negative 2/3. That's true, okay? So I wanted to leave that part. So yeah, multiply both sides of the equation by, and the reason I thought of that, if it was equal to negative 2/3, you'd be multiplying by 0. That's not a good thing to do. You wipe out all meaning. So that's what made me think of it. So this gives you x times 3y plus 2 is equal to 5 minus y. Now, I didn't show that I did that. Here's what I did. Multiply this side by 3y, I can't write. 3y plus 2. Boy, y'all write poorly, don't you? Okay. 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 And multiply this side by 3y plus 2. Okay. So that's what I've done. How do you do that? What's your next step? Not step, but how do you proceed? Distribute. Let me write it up here. That would be 3xy plus 2x equal 5 minus y. Now what's our goal here? Solve for y. Isolate the y. So where do you want your y's to be? All on one side, and anything that doesn't have a y in it on the other side. Okay, so what might you do? Tell me. How do you make that happen?
You can subtract 2x.
Subtract 2x from both sides. I will do that here. And add y to both sides. I'll do that there. Okay, here that goes to 0, and these go to 0. So that leaves you on the left. And now I'm doing it in one step. You can take 2 steps if you want to. Okay, I just don't have much room. So this is 3xy plus y. All the y's are over here, and all the non-y's are over here. 5 minus 2x. Right? Now, what's the goal? Solve for y. Isolate the y. What can you do to isolate that y? Not yet. Not quite. Say again? Yes, take out a y. Wipe it out. No, she means factor it out. Yes, that's what we mean. Okay, y times, what would be left over? 3x plus 1. That's why we can't divide by 3x, you see? You divide by 3x plus 1. Is equal to, you didn't do anything over here, so that's still 5 minus 2x. Okay? Get out of there. Okay, still, what's the goal here? Solve for y. We got one more step. What is it? Here's the y. We want to isolate it. Divide by 3x plus 1. Okay? Okay? That wipes this out over here, and you have y is equal to 5 minus 2x over 3x plus 1. All right. Get out of there. Okay. There's two more little steps. Well, one's a little step, one's a big step. What's the next one? Change the y to f inverse of x is equal to 5 minus 2x over 3x plus 1. All right. We think we found the inverse. We have to verify it. That's the long step. All this is fun, right? That's the harder part, sort of. Okay? So, what I'm going to do, because I don't have much room on the slide, unless anyone needs it a little bit longer, is erase everything but f and f inverse. Is that okay? All right. So let me get rid of that. Okay. So I'll erase this. I could have left that maybe, but I don't need it. Okay. I often wonder what this looks like at home and start seeing stuff just starts disappearing off the screen. Oh! I erased the f inverse. Actually, I did that on purpose so I could write it up here next to that. Can you believe that? Nah. Okay. F inverse, come on, tell me what it was.
5 minus 2x.
5 minus 2x. You better be telling me the truth. Over what? 3x plus 1. Okay. All right. It was all on purpose. How do we verify? Plug it into what? Say again? What's the verification? For these two to be... Say again? Not quite. F of f inverse. That's it. F of f inverse of x. Okay? And what would that be? Don't mess with the outer one yet. Write that down, f. And instead of f inverse, you write down what that is. And what is it? 5 minus 2x. They better have told me the truth. Okay? Over 3x plus 1. Okay? Now, what does that indicate you need to do? What does the f function do for you? Starts with the number 5. So let's start with number 5. Okay? So this will be 5 minus. And then you put in whatever is in your parentheses. Here it was just x. Here is that mess. So what is that mess? 5 minus 2x over 3x plus 1. All right? Divided by 3 times 5 minus 2x over 3x plus 1. Plus 2. Perfect. All right. Now you got a mess on your hand, don't you? Okay. This is sometimes called a complex fraction, really don't like that term too much because complex in math usually mean something like a square root of -1, you know, like I, imaginary numbers. We're not talking about that. It's what I call a complicated fraction. And y'all say, well, all fractions are complicated. No, they're not. This is more complicated. So how we go about solving this or finding the value for it? Let's multiply numerator and denominator by the least common denominator of all our denominators, which are 3x plus 1. So we're going to multiply this numerator by 3x plus 1 and multiply the denominator by 3x plus 1. Why is that legal in most states? 3x plus 1 over 3x plus 1 is equal to 1. And you can do that anytime you want to. Now, what does that do for you? Let's distribute it here, and that gives you 5 times 3x plus 1 minus, and this will wipe out that denominator. So then you have a 5 minus 2x. Now notice, following the minus sign, I put that in parentheses. If you just wrote it down, you're going to wind up probably with the wrong answer. Okay? That'll be your numerator. You tell me what the denominator is. Here, the 3x plus 1's go out, leaving you 3 times 5 minus 2x. See, this 3x plus 1 is going to cancel that now, so you're left with 3 times 5 minus 2x, right? 5 minus 2x plus what? 2 times 3x plus 1. All right. Now what do you think we're going to do next? Distribute. In the numerator, we'll have this start with distributing the 5 over the other 2, and what does that give us? 15x. Does everybody see that? 5 times 3x is 15x. Continue. Plus 5. Second. Minus 5. Plus 2x. Good. You didn't let that stinking minus sign trip you up. That was excellent. Then distribute in the denominator, and what do you get? 15 minus 6x, is that what I heard? Okay, continue. Plus 6x plus 2. All right. All right. Let's see what we got now. Notice anything in the numerator that can be simplified? Plus 5 minus 5 adds to 0. How about in the denominator? Minus 6x plus 6x. That's added to 0. So that gives us 15x plus 2x is what? 17x in the denominator. 17, and guess what, folks? Those divide out, and you equal x, which is exactly what it has to if these are inverses of each other. All right, wasn't that fun? Say yes. Okay, all right. Now, the job is halfway done, right? Because what's the next step? Yes, then you do F inverse of F of x. And you know how to do that, don't you? You just turn it around and put the F of x inside, the F inverse on the outside, and do the same thing. It will be another similar process, but it would take a lot of time, class time, that you really want to move on to something else, don't you? So, as good math professors say, we'll leave that to the student, you know. Have you ever heard that before? Oh, you haven't lived. Okay. Even in books sometimes they say, the calculations here are left to the student. You know, that means it was way too complicated for them to use up all the room on the text. So we'll leave that to the student. But you know how to do it, right? And if that indeed comes out being x also, cha-ching, we have inverses. And that would be the inverse. So I'm convinced There it is. Find the inverse of that. There it is. Okay. I have to read my right. 5 minus 2x over 3x. Okay. Do you mind if we skip the second confirmation? Badly? Do you mind? Okay. All right. Let's move on. By the way, yes, he minds. Okay, yeah.
Before we distribute the 5 times 3x plus 1 in the bottom,
Right here?
can we just cancel those out? Because then you're going to have 5 over 5 is an equal x. What do you have to distribute?
Okay.
Because the 3x plus 1, can't you just cancel it? And 5
Wait. You mean do these two out?
And, the 5
And
minus
those
3x,
two out?
You're left with 5 over 5.
And that leaves you 5 over what?
5 over 5.
Oh, 5 over 5, which is 1. Is that x? Oh, it's 1.
Okay.
All right. So probably not. You would think they're not inverses of each other. Let's see. That sounds like an awfully good plan, doesn't it? So let's see. What if that number had been 53 minus 5 over 35 plus 23? What if we cancel those 3's out and those 5's out? Would that work too? You get 5 over 5, and that's 1. Can you cancel that way? If you do, you're going to be in sad shape Tuesday, okay? You can't do that. Okay, the way I like to say it is you can only divide out. We're not canceling, we're dividing. You can only divide out things that are multiplied. In other words, you would have to be able to extract a 3x plus 1 from both terms, here and here, before you could divide it out. So that's why you can't do pieces any more than you can do digits. Okay. Good question. I'm glad it was asked rather than done on the test. Okay, so good to do that. All right. As I was starting to say, there is a checkpoint at the bottom of the page. Well worth your effort. Once you do verify the second, F inverse of F, then do the checkpoint. All right. Let's see how they did it. Well, we've already seen how they did it because they have the wrong problem. So we can move on to example 7. I don't think they have it on the slide set, so let's see. Wait a minute. Okay. Catch this. Okay. Up here, they had the wrong problem, but down here they had the right one. So look at this, folks. We have, now they didn't show you how they get it. They just said magically, there's the graph. And it is 1-to-1 because no horizontal line crosses more than once. Okay? I don't agree with this too much. It needs to come down a little bit. Okay? But it's okay. Now, but it is 1-to-1. So they do the rest of it. The graph passes the horizontal line test, so you know it's 1-to-1. It does have an inverse. Here's the function. First step, change the f of x to y, just like you did. Next step, exchange the x's and y, just like you did. Okay? Next step, solve for y. So they multiplied, just like you did, the denominator by both sides of the numerator. It wiped it out on this side, and that's what you have. Okay? Now you have to distribute the left-hand side, 3xy plus 2x equal 5 minus y, distributive property. Okay? And now they move terms, okay? Getting all the y's on one term by adding y to both sides, getting all the non-y's to the other side by subtracting 2x. Okay? Now that you've done that, factor out the y, isolating the y, and then we'll divide by the 3x plus 1, just like you did, solve for y. That's what we suggest is your F inverse. Okay. Now, let's see how much they do. Didn't I tell you they do this? They did it worse than I did. check the f of f inverse is equal to x and f inverse of f of x equal to x. See? Typical math book cop-out, okay? They didn't do the hard work. We did the first one. You get to do the second one. Oh, and that was the last slide. So let's do example 7. What in the world are you doing? Okay. Example 7. Find the inverse of f of x is equal to the square root of 2x minus 3. Okay? What have you got to do first? And normally I'd say talk your way through it. This time I think we actually have to do it. What is the first step? Yes, verify that it's 1-to-1. How do we do that? Graphing it. Okay? That's kind of a big boo hiss, but I think we can live with it. What can you tell me about the graph of this? Good things to know about the graph. Same thing we did before. Domains, intercept, x-intercept, y-intercept, and are there any asymptotes? This one, I think probably no asymptotes. There's no x in the denominator, so we're not going to worry with that one. Okay? So, can you tell me the domain? What feature defines a domain here? What can you tell me? Normally you say domain is all real numbers unless you have problems. Do we have problems? Say again? A little out. No negative. Is that what I heard? Okay. In other words, written in math speak, that says 2x minus 3 has to be greater than or equal to 0. That means no negatives. All greater than or equal to 0. Solve that equation. Or inequality. Say again? Add 3 to both sides. That doesn't change the direction. That gives us 2x is greater than or equal to 3. And divide by 2. That doesn't change because that's a positive number. And that gives us x is greater than or equal to 3 halves. I can't write. I can't read. I can't do anything. Okay. Okay. 3 halves. All right. Now, with that in mind, I'm going to erase what we just did. Well, let's go on and graph it first. Okay. So I'm going to put the y-axis here. Now, here's the other thing. While we talk about domain, let's talk about range. What's the range of that function? All real numbers? What does this mean? Notice the square root symbol. Which square root symbol is it? Principal. Positive square root number. If you don't see a minus sign ahead of it, you understand it's the positive of the principal square root. So this is everything greater than 0. So I can put my y-axis way down there if I want to, because we're not going to have any negatives. Okay? And let's tick off a few points here. 1, 2, 3, 4, 5, 6. Okay? I'll tick off a few here. 1, 2, 3, 4, 5. I won't need them, but I'll tick them off anyway. Okay. Now, got to do the first one. 3 halves, right there. And by the way, when x is equal to 3 halves, I plotted it. I shouldn't have done that. When x is equal to 3 halves, which it can be, 2 times 3 halves is 2 times 3 halves is 3 minus 3 is 0. Square root of 0 is 0. So I plotted it right. Now, the rest of it, this looks just like a square root. It is a square root function. And that's going to rise here. It's going to be half of a sleeping parabola. Something like that. Right? You can plot points if you want to. Here's how I would if I were going to. What's an easy square root to take? I've already done 0, so you can't do that. I No, the square root of 1. So if this inside was 1, what would x have to be? 2. 2 times 2 is 4 minus 3 is 1. And square root of 1 is 1. So when x equals 2, y is equal to 1. Oh, look at that. I came pretty close to it. Okay? Next easy point to take the square root of would be 4. Oh, good test. Okay? And if this in here is equal to 4, just think, equal 4, add 3 to both sides. You don't get a fraction form, but that's okay. If that's equal 4, that would be 7. 2x equals 7. X equals 7 halves, which is 3 1/2. So when x equals 3 1/2, this should be 2, because the square root of 4 is 2. Hey, I came out pretty good there, didn't I? Okay? And you could keep going and do, next easy thing to do would be 9. So this would be 9. Add 3 to both sides, that would be 12. X would equal 6. 1, 2, 3, 4. Good. No, good. 1, 2, 3, 4. I got it on here. So 6 would be 3. Okay. So I wasn't too far off. Adjusted it some. But yeah, the main deal here is this a one-to-one function? Yes, strictly increasing. Given that, of course, did I already erase that? X has to be greater than, oh, here it is, greater than or equal to 3 halves. Okay? But yeah, it's a one-to-one function. Okay? So we've done the first step. Let me erase everything but what I've written down there. Ooh, I erased too much. Okay. Okay. Let me get my dividing line back. Okay. So what's the next step? You verified it is a one-to-one function. It does have a second. Set it to y. Okay, so this is y is equal to the square root of 2x minus 3. Next. Swap them. Okay, and that would read x is equal to the square root of 2y minus 3. Next. Solve for y. It sounds really easy, doesn't it? What are we going to have to do here? Ooh, y is in bad trouble, isn't it? It's captured by a square root sign and messed up in there too. So what do? Square both sides. Okay? That removes the square root, so this gives us x squared is equal to 2y minus 3. Now what? Second? Add 3 to both sides? Good. Okay? And that gives you, I'm going to switch sides, okay? 2y is equal to x squared plus 3. Divided by 2. I don't know which way I want to do it. I'll just do it this way. Divided by 2. We found our y, and what is that equal to? F inverse of x. So that's what we propose, okay? Now, little bit of an issue here now. I look at that and say, I know that's not a one-to-one function, because that's going to form a parabola of some nature. And that's not going to fail the horizontal line test. But I want to remind you that this x here used to be the y up here, right? And that y had to be, remember, positive. Okay? So that means we're only going to have positive x's. As long as you only have positive x's, this will be okay. You're not going to go on the negative side of things. So we're all right. Goodness, we were afraid of that, weren't we? I knew you were worried about it. Okay. Now, again, look at the book. they say they get this, and then they don't do another thing. Very last sentence. Verify the f of f inverse is x and f inverse of f is x. Let's do at least one of those. Yes. Okay, I said this probably before you came in. Not everybody's turned in the quiz, so I can't turn them back. You can see them before you leave. So if you want to wait and see them before you leave, you can. Huh? Okay, well, I'll at least let you see it, but I can't return it to you. Okay? Pages and pages. Here we go. Okay, and if you want to see it in more detail, I'll be on the Birmingham campus tomorrow from 8 to 12 pretty much. It'll be one time I have to leave, I know. And then Monday I'll be in my office here, 8 to 10, and then again 3:45 to 6. So either one of those times you can come and we can work through anything you may have missed. Okay. All right, so let's do one of them. Which one you want to do? We're going to do one verification, not both. On your test, if it says verify, guess what? You do both. Okay, but let's do one here. Which one you want to do? Since we didn't do it before, let's do f inverse of f of x. You tell me what we do. Leave the f inverse alone for now and plug in what f of x is. And what is it? Okay, the square root of 2x minus 3. Now watch it sinking slowly into the west. Okay. So what do we do now? Plug it in to f inverse. Well, f inverse says you start with whatever's in the parentheses, which is square root of 2x minus 3, and you square it, then you add 3, and then you divide by 2. So how do we square a square root? You just, this wipes that out, and you're left with 2x minus 3 plus 3 over 2. Boy, this is a lot easier, isn't it? What happens here? 3's go, because that adds a 0, and 2's go, and that gives you x. Whew, that was nice. That's so easy we might be able to do the other one, you think? Okay, let's do it. All right, let's try f of f inverse. Whoa. I say it right and write it wrong. Okay. F of f inverse of x would be f of x squared plus 3 over 2, and that tells us, what does the f function tell us to do? Take the square root of 2 times whatever's in parentheses, which is x squared plus 3 over 2, and then subtract 3 from it, all under that radical. What do you notice you could do first? The 2's divide away. They don't cancel, they divide out, okay? And then the plus 3 minus 3 is 0, and that gives you square root of x squared, which is x. Ding, 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 we got it. Again, not bad, folks. All right, so sure enough, they are inverses of each other, because both of those yielded an x, okay? Now, this you didn't see it, but there's the x, okay? Everything else disappeared. All right, Now, let's go back for a moment. I guess I have to erase all this. Okay. Oh, I almost did it, but I didn't quite. Okay. We verified it. That's all you had to do, but the book does one more step, which is not a bad thing to do, but I sure wouldn't spend my time doing it. But we're going to now because we got time, just a little bit. Where is it? There it is. Okay. Let's go back and graph that thing again. Okay. Remember how it was? 1, 2, 3, 4, 5, 6, 7. 3 halves. 1, 2, 3, 4, 5, 6, 7. And then it was at 2, 1. And remind me, help me. Second? 3.5, that's right. 3.5 was 2. 1, 2, 3.5 is 2. Somewhere right about there. And then the next one was at 6. 4, 5, 6, and that was at 3. Okay. So this was our square root function. F of x is equal to the square root of 2x minus 3. Okay. Then we're going to do this one, but remember we're limited now because the x's were the y's. The y's were only positive, so we're only going to take positive x's down here. And when x equals 0, y is equal to, let's do this in a different color. Give me a color. Second? Red, okay. Oh, you didn't say red. What color did you want? Green. Okay, I can't hear. Okay. So when x equals 0, y is equal to, or f inverse is equal to? X equals 0. Second? 3 over 2, which is 1.5. That makes sense, doesn't it? Next, x equal, say, I don't want to do 1. Yeah, let's do 1. X equal 1. 2. X equal 1, this would be 2. X equal 2, what would you get? Seven halves, which would be right about there. X equal 3. Whoa. Yeah, you would get 6. 3, 6. That's about as far as I can go. And how does this do? That's a half a parabola. And guess what this is? That's why I'm glad you didn't say red. Because here is your dividing line. The y is equal to x. And you see, almost perfect image across the identity function. Make sense? You don't have to do that, but if you wanted plenty of fun time, you could do it. Checkpoint here, interesting checkpoint here. They give you a cube root in this case, so that would be fun to do. So do it. Let's do the vocabulary and see what we've got here. Any questions before we move on to vocabulary? Okay, if f of g of x and g of f of x are both equal to x, then the function g is the blank function of the function f. Inverse function, y'all are good. Number 2, the inverse function of f is denoted by f with a superscript -1. You got it. Number 3, the domain of f is the blank of f inverse. Range of f inverse, and the blank of f inverse is the range of f. Domain of f inverse is the range of f. Perfect. Number 4, the graphs of f and f inverse are reflections of each other in the line y is equal to x. Perfect. The identity function. Okay? Number 5. A function f is blank when each value of the dependent variable corresponds to exactly one value of the independent variable. 1 to 1. Excellent. And number 6. The graphical test of the existence of an inverse function is the blank line test. Horizontal line test. I can tell Ryan wants to be horizontal. No, okay. Yeah, okay, never mind. All right, homework exercises here would be any of the odds, 7 through 13. They're all at Calc Chat. 9's at Calc View. Either 15 or 17, they're both at Calc Chat. 15's at Calc View. 19, that's at Calc Chat. Any of the odds, 21 to 31, they're all at Calc Chat. 23's at Calc View. 33 should be at Calc Chat. 35's at Calc Chat. Either 37 or 39, they're both at Calc Chat. Either 41 or 43, they're both at Calc Chat. For 41's at Calc View. Any of the odds 45 through 53, they're all at Calc Chat. 45's at Calc View. Any of the odds 55 to 69, they're all at Calc Chat. 61's at Calc View. Any of the odds 71 to 77, they're all at Calc Chat. 79 to 83, they're all at Calc Chat. 85 or 87, they're both at Calc Chat. 89's at Calc Chat. 91's a true false. It should be at Calc Chat. 93 should be at Calc Chat. And 95 is a proof. You can do that if you'd like, and you can think about doing 97 if you'd like. 97 and or 99. Okay? And then there's one more, 101. You can look at that if you'd like. We're not doing 1.10, okay? So, by the way, I was at a meeting in Tuscaloosa several Fridays ago, and there was a big discussion over whether variation should be included in this course or not. I think they decided it would be optional. Okay, so don't worry about 1.10. If you need some more, on pages 104, 105, there is a great chapter summary, okay? And it's split up by sections, so you don't have to know necessarily, but it's not a bad thing to know, what's in 1.1, 2, and 3. We didn't cover that. But beginning in 1.4, 1.4 through 1.9, they have a lot of things here that probably, if I were doing it as lazy as I am, I'd probably put some of this, the key stuff, on your formula and equation sheet. You don't have to put it all for sure, but some of that might be quite useful. Okay? Then you have a bunch of review exercises, and they also break these down by sections. So you don't need to do the ones for 1.1, 1.2, or 1.3 unless you just want to. They would be fun. But beginning with 1.4 on page 107, you could do either 43 or 45. They're both at Calc Chat. 47's at Calc Chat, 49's at Calc Chat, 51's at Calc Chat, 53's at Calc Chat, and then in 1.5, 55's at Calc Chat, 57, 59, 61, 63, and 65. In 1.6, 67, 69. In 1.7, any of the odds 71 to 79. In 1.8, 81, 83, or 85. They're all at Calc Chat. And then in 1.9, 87, 89, 91, and 93. You don't need to do the 1.10 unless you just want to. Then there's a chapter test. Okay? Now here's a little difference in the chapter test. If I'm not mistaken, I may be mistaken. Oh, no, these are checkpoints. By the way, if you didn't know it, the checkpoints have answers in the back, too. I just realized that. In the chapter test, and actually, let me back off here for a moment. In the review exercises, I said you could do the odds, because those are at Calc Chat, but odds and evens are in the back of the book, I think. Check and make sure they're in yours. This may only be because it's the instructor edition. Let me just check. Yeah, I think this is just because it's instructor edition. So maybe they're not. But I think the chapter test, all the answers there. But they're only the odds are at Calc Chat. So again, you can do the odds. Don't worry about the ones that cover the first 3 sections. You would pick up with number 10, even though that's an even problem. 10 through 23 would all be good ones that you could do. Okay? You don't have to worry about the first 9 or the last 3. Okay. Oh, goodness, I'm about to lose everything here. How are we doing on time? Oh, man, it's so sad. Yes. You can write whatever you want to on there. You can write it in whatever language you want. I mean, you can do whatever you want to on those sheets. Okay? So. Oh, absolutely. Bring your calculators and know how to use them. Okay? I don't have time, and you don't have time for me to be explaining how to do thus and so on your calculator. So use your calculators when you're doing the homework exercises. So no, I'm not going to do it. It's just going to be problem solving. Oh, is that what you asked? Yeah. I'm sorry. I thought you said calculators. I'm glad you asked about calculators anyway, so I could answer it even though you didn't ask about it. Okay. Because I do want you to bring your calculator. I won't have any up here. Okay, so.
Can I listen to my quiz?
I'm sorry?
My quiz.
Oh, okay, sure. Anyone who wants to see the quiz? Maybe so. Okay. All right. Now, don't leave with them because I have to hang on to them until I get them all in. Jaden is here, right? You wrote me a book, didn't you? Okay. All right. Don't leave with it. Yeah, but I'm just seeing alphabetically. Hemi is not here. Dana is waiting. Okay. Don't leave. Okay. Sharona's not waiting, are you? Shawanda's not waiting. Josh is gone. Daria? Not, oh, yeah, there you are. Did I mark you here today?
She was like.
Huh?
It's okay.
I'm sorry?
Shawanda, I don't know how to say it. She wanted it.
Okay, I'll get it. You're just not up here. Okay. Rachel, did you think yours? Oh, okay. I didn't see you.
I'm sorry. Which way do I go?
Okay. Okay. Okay, don't leave with them. Okay. Alphabetically, who's next? Okay. Oh, turning them in. Good. You could do that anytime. Okay. Brooks, Tammy, not here. Sharona, not here. Shalonda is. I'll pull hers out because she's very demanding. Okay. Okay, I'm just kidding. Okay, Josh, not here. Short, you ready to turn it in? Okay, I have to have another stack. Oh, man. The one's not done. Okay, good. Richard. Karen is waiting? Yes. Janae. Anna. Kayla. Yoshi. Okay. Amon. Amber. Oh, yeah, Amber, I see you. I didn't look far enough to my right. Ooh, I'm about to lose them. Let me set some of these down. Okay, put them right there. Oh, yes, I think that's the right place. Yes, it is. Okay. Yeah, okay, good deal. Thank you. Tiffany didn't wait. Ryan waited. Just on top there if you want to do them. Okay, Tyler didn't wait. Either Tyler. Okay, good deal. Thank you. Everybody get to see it that wanted to see it. That's why I put yours there. I put yours on top of it. There you are. I didn't read the note. Oh, no. Okay. It wasn't a note. Now you answered the problem. Okay. Oh, you're turning in. Good deal. Thank you. All right.
I will have to ask questions or?
Sure.
Oh, okay.
I'm going to shut down the